Hi, this is our third lecture about conventional hemodialysis. In these lectures, I discuss my book, A Nephrotube Synopsis of Conventional Hemodialysis. In this lecture, we will talk in details about dialysis water unit. In the description of this video in YouTube, below the video, you will find some important links. The first link is a link to this same lecture, but in Arabic language, for those who like to watch the lecture in Arabic. You'll find also a link to the playlist of video lectures about this book. You will find the link for the English playlist and Arabic playlist. You'll find link to download this book for free. You'll find link to download the PDF of this lecture for free if you like to use it. You will find a link for my website Nephrotube, nephrotube.com, where you will find more lectures about nephrology than hemodialysis lectures. And finally, you will find a link to Nephrotube social media accounts, the WhatsApp group, the Telegram channel, the Facebook group. You can join us to be always updated by the activities of Nephrotube. And finally, it's better to subscribe to our channel and to make the notifications on from our channel, so you will be notified once we upload new lectures. At first, I want to mention that our hemodialysis patients use a lot of water, a large volume of water. During one hemodialysis treatment, one hemodialysis session for one patient, usually this patient is exposed to 120 to 200 liters of dialysate. We will talk about the dialysate itself later in the coming lecture, but the dialysate in general is formed of water. So during each hemodialysis session, the patient is exposed to a very large amount of water, and most of this volume of water will be lost in the drain. As the patient is exposed to a large amount of water, it is important to be sure that this water is pure and the dialysate formed from this water is also pure. It must be pure for any contaminants that if it enters the patient's bloodstream can cause harm. The main source of the dialysis water is the city tap water, which is usually contain contaminants and ions that must be cleared before this water forms the dialysate that will be exposed to the patient blood. This is an example. This table shows some of the water contaminants and their adverse effects if these contaminants reach the patient's blood. So, for example, aluminium can cause neurological deterioration, encephalopathy, bone disease, anemia, and so on. Chlorine can cause hemolysis. And the problem in the water contamination of the dialysis that this will not affect only one patient. If there is any abnormality or contamination of the water unit, this will affect mostly all the patients in the unit, and it may cause a disaster. Therefore, using a reliable water treatment system and regular water quality assessment are essential. After this introduction, I will start my lecture, and this is my talk outline. I will start by how we purify water, tap water. Then I will talk about water piping system, and then I will talk about disinfection, then the standards of treated pure water, and the frequency of quality monitoring of the water, and finally what is called the green dialysis or green detergent. Starting by the first point, which is tap water purification. How we pure the tap water? How we purify the tap water? Tap water is purified through two steps. The tap water at first goes through what is called water pre-treatment system, and this is step one, which will form what is called feed water or pre-treated water. So the pre-treatment system will form what is called pre-treated water. Then the feed water or the pre-treated water will go through the second step, which is called water treatment unit or water treatment system, or called water purification system. And this is for what is called, and this forms what is called treated pure water, product water, or also can be called permeate. And this pure water will join the hemodialysis machine to form the final dialysate that will be used in dialysis. I will start now by first step, the details of first step, which is called water pre-treatment system, which will form the feed water or what is called the pre-treated water. The water that comes from the city, which is a city tap water, will pass through multiple filters. Each filter of them is important to form a special function. But I have to mention first, in many centers, especially in areas where there is a possibility to lose the city tap water due to maintenance or whatever, most of these centers put at the start here, they put a tank, a primary tank, to store water, to get water supply in cases if the city tap water is lost due to any reason. The city tap water at first passes through what is called multimedia filter, or can be called also depth filter or sediment filter. This filter eliminates large particles and sediments ranging from 5 to 500 micron from the water, such as sand, clay, rust, plant debris, and so on. I want to show you the internal structure of the multimedia filter, although I didn't use this diagram in my book. The multimedia filter is composed of multi-layers, layer of gravel, layer of garnet, then sand, then anthracite. These layers, the water comes from here, from this tube, then pushed through this tube to the bottom of the multimedia filter. Then the water will move by pressure through the multiple layers, and as I go up, the pores between the different layers become smaller. For example, the layers between the particles of garnet is smaller than gravel, and the sand is smaller than garnet, and so on. And these layers will eliminate and prevent particles and sediments to move with water, and the water coming out from here will be clear from these particles between 5 and 500 micron. And this is why what I am showing here, you will find here there is a line where, or port where the water is going in through the multimedia filter, and this is the line where, or the port where the water will come out to go to the next step. The next step, the water will go through carbon filter. The main action of this activated carbon filter, or sometimes it can be called charcoal filter, activated charcoal filter, is to remove chlorine and chloramine from the tap water. Because if chlorine and chloramine reach the reverse osmosis membrane, the RO membrane that I will talk about in step 2, they will damage the RO membrane, and it is important to check daily the chlorine level in the water, as I will mention later, to be sure that the chlorine in the water is within the accepted level, to be sure that the carbon filter is working in a correct manner. Again, this is the internal structure of the carbon filter, gravel, and finally the activated carbon. Usually most centers put two carbon filters following each other. One is called working or worker carbon filter, and the other is the polisher carbon tank, where water goes first through the first tank, then the second, and from the second the water will go out to the next step. The next step in the water pre-treatment system, which is step 1 in the water purification, is the softener, water softener. The tap water is considered as hard because it contains calcium and magnesium. And it is important to remove calcium and magnesium from the water, because if calcium and magnesium reach the RO membrane in the next step, they also will cause its fouling and they will damage it. The softener is full of sodium, and the sodium in the softener will exchange with the calcium and the magnesium in the tap water to remove them. And if the sodium in the softener is used or abolished, you can recharge the softener from the brine tank. You will find a brine tank beside the softener to recharge this softener with sodium that will exchange with the calcium and the magnesium in the water. Brine tank, brine means concentrated sodium chloride. So this brine tank contains concentrated sodium chloride. I will show you how this softener work by showing you the internal structure of this softener. In this softener, there are resin beads. On these resin beads, you will find sodium is attached. When water passes through these resin beads, the resin beads will release sodium in exchange with calcium and magnesium. And this calcium and magnesium will bind to this resin. So the water coming out from the softener will have less calcium and magnesium, but high level of sodium. And this sodium will be removed later on by the RO system that I will mention later. Again, why we are trying to remove calcium and magnesium? Because they can damage the RO membrane. Before going the next step, I want to mention that the carbon filter and softener, water softener, may be exchanged in some centers. Here in Egypt, the practice is to put the carbon filter before the softener, but in some areas out of Egypt, they put the softener before the carbon filter. The next step after the softener is the pre-RO microfilter. The coming step in the step 2 is called the reverse osmosis. Before the reverse osmosis, it is better to put these cartridge filters or microfilters. We can put 1 or 2 with different sizes. We can start by 5 micron microfilter and put after it another filter of 4 micron, then another one with 3 micron with decreasing sizes to remove small particles. Here in Egypt, the practice is to put only one size of microfilter before the reverse osmosis. What is the importance of these microfilters? Is to remove particles that are released from the softener or carbon filter. The softener or carbon filter themselves release some particles that must be removed before the water reaches the RO, and this will be removed by the pre-RO microfilter. Then the water, which is called the feed water, is now formed. It is called the feed water or pre-treated water that will go to step 2 water treatment purification system. Before going to step 2 treated water purification system, I want to add some points related to this step 1. You can find other microfilters, cartridge filters, with various different sizes between different tanks. For example, this is an example of one of the practices here in Egypt. They put here a 25 microfilter and 10 microfilter. The size and distribution of these filters depends on local center's policy, and it may differ from one center to another. Another point to add here, I want to add here that there may be some additional optional steps that can be used here before the multimedia filter at the start. So what are the optional steps that may be present at the beginning? One of them, there may be here a valve that blends hot water and cold water together in extremely cold environments. In extremely cold environment, the water that enters this system may be very cold, so there may be here a valve that blends hot and cold water to maintain a constant temperature of the water in the water unit. Also, in some areas that have a very alkaline water, where the city tap water is very alkaline, they put here an acid feed pump that add HCl to the alkaline water to buffer it. Because if the alkaline water reaches the carbon filter, it will decrease the ability of carbon filter to remove chlorine and chloramine, and we are afraid from chlorine and chloramine to reach the reverse osmosis in step 2 and destruct it. Okay. Another point I want to add here is that there are pressure monitors before every tank and after every tank. The pressure in these pressure gauges or pressure monitors must be the same before and after each tank. So the pressure in here before the carbon tank must be the same as that after the carbon tank. If there is a difference in pressure between these two pressure monitors, so there is a problem in this tank. If the pressure is high in the pressure monitor before the tank than that after the tank, this means that this tank or filter becomes obstructed, which lead to increased pressure difference between these tanks. The international references said that if the pressure difference between the two pressure monitors is more than 10 psi, if you look here, this is a photo of one of the pressure monitors here in Egypt. You will find two units, the bar and the psi. The bar, one bar equal about 0.68 psi. Here in Egypt, if the difference between the two monitors here and here is 1 bar or more, so we start to make backwash for the tank, or even maybe change it according to its condition. And what is backwash I will mention later. But the international references mention that if the difference between the two pressure monitors is about 10 psi, which is about 0.68 bar, you have to take an action as backwash or changing the filter. So the references here in Egypt may be different than some of the mentioned references. By the way, PSI is the abbreviation of pound per square inch. So if there is a difference in this pressure, or even periodically, filters should be backwashed at least daily when no patients are connected to the hemodialysis machine. And this is a photo from one of tanks here in Egypt. You can adjust from this apparatus a timer, so the backwash can be done automatically in the absence of the water unit instructor in the absence of hemodialysis patients connected to the hemodialysis machine. I will show how backwash works. For example, on the multimedia filter, and the same will happen for other filters and tanks. In the backwash, we push water in opposite direction. Normally, for water purification, the water enters from here, then passes through the layers from down till upward. But in the backwash, we will move water in the opposite direction. We will move water from here. The water will start to move from the first upward layer going down, and it will push the debris with it to go out from the filter of the tank. So the filter will be not obstructed now, because we get rid out of the particles, including the particles of this filter. Now we have to go to the next step. Now we formed what is called the feed water or pre-treated water, that will go to the next step, which is called water treatment system or purification system. Before going step 2, I want to mention another point regarding the pressure differences between the pressure monitor before and after each tank. When you install the tank and the tank is working properly and the water is meeting the standard quality that I will mention later, at this time you will know the baseline pressures before and after the tank. You will know them, and this will be the baseline and the standard of this tank. If the pressure in these pressure monitors decreased or went down, although the flow is good within the tank, this means that this tank or filter lost its integrity. It is not working well because the pressure becomes low, although the flow is going through it. So this tank lost its integrity. So after forming the feed water, we will go to step 2. Step 2 can be formed by one of two systems. One is called reverse osmosis, and the other is called deionization. Actually, the deionization system is rarely used as an alternative to the reverse osmosis. Theoretically, it can be used instead of reverse osmosis. We can use the reverse osmosis or the deionization, but actually in the practice, it is rarely to use deionization alone, and I will mention later why. But usually the deionization, if it is used in conjugation with the reverse osmosis. It can be used after the reverse osmosis for more purification of the water. Let's go through the details of both of them. I will start by the details of reverse osmosis. What is the reverse osmosis and how it forms the product water or permeate? The feed water that comes from step 1 will go through the reverse osmosis. The reverse osmosis has here a semi-permeable membrane. So water in this compartment will pass from here to here under high pressure through a semi-permeable membrane here. This high pressure will move water, clear water here, pure water here, which is called product water or permeate, and excluding back, this membrane will exclude back ions, bacteria, and toxins. So the water excluded here contains ions, bacteria, and endotoxin, and the water moved here is totally clear, and this product water will go to the hemodialysis machine to form the dialysate. And this rejected water that contains ions, bacteria, and toxin will go to the drain. And that's why it is called reverse osmosis. Why it is called reverse osmosis? Because this mechanism squeeze water here in a direction against high osmolar pressure. Here there is a lot of ions in this compartment with high osmolar pressure, but I move water in this direction against this high osmotic concentration in the rejected water. That's why it is called reverse osmosis. Most of the centers have only one reverse osmosis membrane in hemodialysis unit, but in certain areas in the world, if the quality of the water, of the product water that comes out from the RO is not satisfying, and it is not consistent with the quality of the water that is essential to form the dialysate, these centers can use more than one RO. They can use two ROs, two-stage RO or double RO, to reach the standard quality of the feed water. How to monitor the efficacy of RO? How to monitor that the RO is working well and the product water is in the correct way? Two methods for monitoring the efficacy RO membrane. The most commonly used, and here in Egypt we only use this method, is the percent rejection. In the percent rejection, we measure what is called TDS, total dissolved solutes in the water. By this apparatus, you can measure the conductivity of the water through measuring total dissolved solutes. You use this equation. You must measure the TDS in the feed water and the TDS in the product water, and then make this equation. The normal result must be that the rejected water must be more than 90% of the feed water. Okay, the percent of rejection must be more than 90% of the feed water, because the reverse osmosis normally exclude 90 to 90% of ionic compounds and more than 95% of the contaminants as ions, bacteria, and endotoxins. So the amount of rejected water is very, very large. It must be more than 90%. If the rejected water is less than 90%, so the membrane must be cleared or changed. Important point that this TDS apparatus gives you a number by a unit called ppm, and ppm is the abbreviation of part per million. It is the same as 1 milligram per liter. So 1 milligram per liter is the same as 1 ppm. The second method to monitor the efficacy of RO membrane is the percent recovery. I think that it is not commonly used. Here we measure the flow by measuring the resistivity of the membrane. You will put here product flow water rate, the flow water rate of the product, divided by the sum of product water flow rate and rejected water flow rate, multiplied by 100. Actually, percent recovery, this percentage, if below than 90%, indicates the need to clear this membrane or change it. So now we formed what is called the product water that came out from the RO. How this product water will be delivered to the hemodialysis machine? The product water can be delivered to the hemodialysis machine by one of two ways. The first is the indirect feed system, and the other is the direct feed system. The indirect feed system that I will start by is the system or the pathway that contains the storage tank. The water that comes out from the RO will go first through the product water storage tank. Then, after the water goes through the product tank, the tank may add some contaminants to this water. So this must be followed by a purification system, whatever by an ultrafilter or ultraviolet radiation. An important point that I want to mention here, that this ultrafilter is also called bacteria endotoxin retentive filter. It can remove particles up to 0.001 to 0.05 micron. Or it can be followed by ultraviolet rays. The disadvantage of this ultraviolet ray, or the pitfall of this ultraviolet ray, the negative side effect of it, that ultraviolet radiation will damage the bacteria. That will cause the release of fragments from the bacterial cell wall as endotoxin. So the ultraviolet irradiation must be followed by ultrafilter or submicron filter. The ultrafilter removes the bacteria and the endotoxin, but the ultraviolet irradiation damages the bacteria. That will lead to release of bacterial fragments and toxins. So it must be followed by another purification step. An important point that I want to mention, that after ultraviolet irradiation, it is better to put the ultrafilter. But in some areas, and this is a common practice in Egypt, we put submicron filter. Submicron filter can remove particles up to 0.22 micron. Here in Egypt, we put after ultraviolet irradiation, we put here submicron filter of 0.22 micron. But actually, this may pass some of the bacterial endotoxin, although the water at the end will be consistent with the quality that we need for the water unit. But it is better not to put 0.2 if the endotoxin filter is not available, the ultrafilter is not available. It's better to put the smallest pore size submicron filter, for example, 0.1 micron. So take care that we have two types of filters, the submicron filters and the ultrafilter. The ultrafilter is the one that is called bacteria endotoxin filter, as it can retain bacteria and endotoxins, while the submicron filter cannot retain to the degree of the ultrafilter. Then this water will be distributed through the distribution closed loop circuit to the hemodialysis machines to form the dialysate, and the water that is not used by the machines will return back to the storage tank. In some units, and I think this is an important point, they put submicron filters in the way of the water that is not used by the machines to clear any contamination that may occur to the water through their moving in the pipes of the distribution system. The second way for the product water that comes out from the RO to go to the hemodialysis machine is the direct feed system. In the direct feed system, there is no tank, but the water goes directly from the RO to the hemodialysis machine. In some references, they mention that they can put also another purification step after the RO, even in the absence of the storage tank. They may put the ultrafilter or the ultraviolet radiation with the same criteria we mentioned before, but in the absence of the storage tank. I want to announce that there is a mistake in my book in page 21. Here I am discussing and explaining RO direct feed system. In this paragraph, I mentioned that the product water moves from the storage tank and be back again to the storage tank. Actually, as I mentioned in the past slides, in the RO direct feed system, there is no storage tank. So the word storage tank here is wrong. As I mentioned in the previous slide, that in the direct system, the water from the RO goes directly to the machines, and from the machines, the water rejoins the feed water. I corrected this mistake in my book, and I uploaded the book again on NephroTube website by the date 26th of May at 9 p.m. Cairo time. So if you downloaded the book before that time, you will find this mistake in the book. If you downloaded the book after this time and date, you will not find this error. The second step, or the second method to purify the dialysis water unit, the dialysis water in step 2, is the deionization. Again, as I mentioned before, that deionization is seldomly used as an alternative to RO, but it is more frequently used in combination. After the RO, we can use it. This is an example. The water that comes out of the RO passes through the deionization method or steps. The deionization steps are two. The first step, that the water is exposed to hydrogen, to exchange hydrogen with the ions in the dialysis water. So here we exchange cations, hydrogen in the deionization step. Okay, here there are resins coated with hydrogen that will exchange with cations in the water. So the water comes out from here with low level of cations. Then the water will expose to other resin that contains OH that will exchange with the anions in the water, and the water comes out of here clear of anions. An important point in deionization, that it must be, this is an obligatory step, it must be followed by ultrafilter, not submicron filter. Ultrafilter, that is the bacteria endotoxin retentive filter. Why? This is because the deionizer mixed beds or resins is a good media and can promote bacterial growth, which can contaminate the water coming out. That is why it must be followed by an ultrafilter. How we can monitor the efficacy of DI? This can be monitored by measuring the resistivity of water coming out of the deionizer. The acceptable level of pure water coming out from the DI, its resistivity must be more than or equal 1 megohms per centimeter. And it is considered, by the way, a very low resistivity because this water is clear of many of ions, especially sodium. Then, how the water coming out from the deionizer can be delivered to the hemodialysis machine? The same way. Theoretically, it can be delivered directly without a tank. Theoretically, you can put a tank, but actually, it is not a practice to put a tank after the deionization, because this may lead to increase the possibility of contamination, as the deionization itself can cause contamination because of the resin beads can promote bacterial growth. So it is not logic or not famous to put a tank after a deionization. Now we formed finally the treated pure water that can reach to the hemodialysis machine to form the dialysate. Let's go through our talk outline. The next coming step is to talk about the water piping distribution system. What about the configuration and the pipes type? It is important that the water distribution system should be carefully designed to avoid contamination and prevent stagnation. What about configuration of the water piping system? It must be in a loop circuit without any branches, dead ends, or area of stagnation. Also, if valves are required from the engineering point of view, the lateral arms length must not exceed the diameter of the principal main pipe circuit. This is important to prevent stagnation and contamination. Again, the water circulation in the piping system must be continuous, even in the absence of the patients, because if the water becomes stagnant, this will lead to bacterial growth and biofilm formation. And if biofilm is formed, as I mentioned later, it usually lead to exchange the piping system of the oil unit. The second point in the distribution, what about the pipes themselves? The pipes must be or should be of a smooth, polished inner surface, and they must be formed of inert materials to avoid chemical contamination. Stainless steel is ideal actually, but the main disadvantage of the stainless steel piping system is the high cost, So the most commonly used actually are the high-grade synthetic polymer materials. The most common used here in Egypt is the PVC pipes because of their lower cost and the ease of handling. The second point is the storage tank and piping system disinfection. It is important for these parts of the water unit to be regularly disinfected to prevent the formation of biofilm, because if biofilm, and also prevent bacterial growth and contamination, because if biofilm is formed or established, this is very challenging and this may require the replacement of the piping system. Different methods of disinfection are available as the chemical method or hot water or ozone. The chemical method can be done at least monthly, and this is very common in Egypt. But the hot water or ozone, these systems provide more frequent disinfection. The next point is, what are the standards of treated pure water? Regarding the standards of the Association for the Advancement of Medical Instrumentation, for the colony forming units, accepted maximum colony forming units of bacteria in the water and accepted maximum endotoxin units level in the permit or product water. Regarding the colony forming units of bacteria, it must be less than 100 colony forming units per mil, and the action level, you have to take an action and check your water unit if the colony forming units of bacteria is more than or equal 50. Regarding the endotoxin level, it is accepted to be less than 0.25 endotoxin unit per mil, and you have to take action if the level of endotoxin units in your water is more than or equal 0.125 endotoxin unit per mil. Regarding other contaminants and ions, these are the numbers recommended by the AMI that may differ from one country to other. Here in Egypt, we have many different numbers than these recommendations, so we have to stick to your local policy regarding the water quality. The coming point is frequency of water unit quality monitoring. How frequent should I monitor my dialysis unit? First, regarding chlorine, and testing for chlorine is examining the carbon filter function. As we mentioned before, carbon filter is essential to remove chlorine. This test for chlorine should be performed at the beginning of every treatment session before patient initiate treatment. Different methods for chlorine testing are available. For example, this liquid that gives you different color degrees according to the level of chlorine. The AMI recommends that chlorine must be less than 0.5 milligram per liter. Here in Egypt, the recommended level is to be below than 0.2 milligram per liter. The yellow color must be very light in this level. And this is another way to measure the chlorine. This is an apparatus that automatically gives you the level of chlorine. This is an automated method, and there may be another methods in different countries. The other chemical contaminants, rather than chlorine, not chloramine as I mentioned here, rather than chlorine, must be tested every 1 to 3 months and can refer to the AMI recommendations or refer to your local policy in your unit. Regarding the TDS, total dissolved solids, must be done at least daily, and this tests the efficacy of the RO membrane, and as I mentioned, that the rejected percentage must be more than or equal to 90%. All of these, the chlorine, other chemicals, and TDS, we are testing the ion levels in the water. Regarding the microbiological test, the colony forming unit and the endotoxin content, they must be tested from every 1 to 3 months, and we mentioned previously the accepted level and the standard level and the level of action. If there is any suspicion of contamination in your unit, for sure the frequency of monitoring of all of these must be more frequent. And finally, I want to talk about what is called the green dialysis or green nephrology. Green dialysis or green nephrology is a very important topic. I'm just highlighting it here, but you can find a lot of literature and articles talking about green nephrology. The main idea of this point is that we all know that there is a deterioration of the global natural environment, and medicine is one of the causes of the deterioration of the global natural environment. And dialysis is one of these major factors affecting the global environment. And this highlights the critical role of us as nephrologists to try making eco-friendly healthcare practices. And there are some suggestions how we can make dialysis green. Green means that it meets the global needs to maintain the global natural environment. For example, we can repurpose the rejected water of the RO. Actually, a large volume of water is rejected by RO and it goes through the drain. We can reuse this RO as example for gardening purposes, toilet cleaning, or even this rejected water can be reused by the RO again. We can recycle it to the RO again to purify it more and use it by the hemodialysis machine. But actually, this may shorten the RO membrane life because this water contains a lot of ions and a lot of bacteria that may affect the RO membrane and cause its fouling. The second point regarding green dialysis as an example, we have to decrease water consumption by trying to discover a method for dialysate regeneration or any way to decrease dialysate flow. Again, we can utilize it. It is not only about water. In dialysis affect global natural environment not only by water consumption, also by energy consumption. So we have to try to utilize renewable energy. The non-infectious garbage from the hemodialysis unit can be recycled for any purposes. And finally, we use a lot of a lot of paper in hemodialysis unit, so they can be recycled, and we have to monitor paper usage to avoid the misuse of this paper by the working staff in the hemodialysis unit. Finally, we finished one of the most important lectures in hemodialysis. My advice, if you didn't before visit a hemodialysis unit or hemodialysis water unit, now after you watch this lecture, you have to go to your water unit and ask the technician of this unit to show you the pressure differences between and before and after every tank, to show you how the backwash is working, to show you the chlorine test, to show you the DTS test. You have to apply this on your water treatment unit. Thank you for watching this lecture and see you in the coming lecture, inshallah.